So in worksheet 3b-3, we have a couple of different types of word problems here. We have consecutive number word problems, so these kind of questions. We have some distance or kind of measurement ones. We have some, this one actually goes here too. We have some money ones, which will be kind of challenging. These are similar to money ones, and we'll kind of go through all the different types. So, for example, number one, it says find three consecutive numbers whose sum is 267. So, a couple key words is the consecutive numbers and the word sum. A consecutive number is, for example, number 6, 7, and 8. These are three consecutive numbers. Now, if I don't know what one of these numbers are, the easiest thing to do is I make 6, and again, I don't know what these numbers are, so I'm just going to say 6 will be x. If 6 was x, then the next number after 6 would be x plus 1. Because this is 6, this would be 7, and the next number after that would be x plus 2. This will give me my three consecutive numbers. It doesn't matter what x is. My next number will be x plus 1, and the next number will be x plus 2. The question says you find three numbers whose sum is 267. My first number is x. My second number is x plus 1. My third number is x plus 2, and that has to equal 267. When I do the math, I'm going to be left with x plus x, which is 3x, plus 1 plus 2 is plus 3, and this gives me 267. And then I will use my algebra skills, and you can solve for the rest. But that's how you do those types of questions. When you're looking for consecutive numbers look like x. The next one will be x plus 1, and the next one is x plus 2. If they're consecutive odd numbers or consecutive even numbers, that doesn't really change either. However, I would always write it out. So say it was consecutive even numbers. So pretend it's 6. The next even number would be 8. The next even number would be 10. So we'll call this x. 8 would be x plus 2, and 10 would be x plus 4. So just be cautious of what they're asking for, and then you would just set it up the exact same way as we did the first question. Okay, so we're going to clear that now. And let's look at a question like number 3. So number 3 says here the dimensions are illustrated. If the perimeter is 52, what is the length? So we know that the formula for perimeter is side plus side plus side plus side. And again, that's this formula because all the sides are different. If it was a rectangle, it'd be 2L plus 2W, but it's not, so we can do this. They've given us the perimeter of 52, so perimeter is 52. One of the sides is x. The other side is x plus 3. The other side is x minus 4. And the other side is 2x minus 2. Not a bad idea to have brackets here. In this situation, it doesn't really matter, so I'm not going to work with them. But you could. I always like to have it just as so I know what I'm doing. 52 is equal to, combine all your x's, 2, 3, 4, 5 x's. Combine all your other terms, and we get positive 3 minus 4 is negative 1, minus 2 is negative 3. Using algebra, I'm going to add 3 to both sides. 55 equals 5x, and then you can solve for the rest when you solve for x. But that's how you do those types of questions. So let's clear this. Okay, let's look at a question, for example, number 6. Start enlarging this a bit so we can see what we're doing here. Number 6, we have an isosceles triangle. An isosceles triangle has two sides that are the same. That's a key about isosceles triangle. One of the equal sides is 3 less than twice the base. So this is base. We'll say this is the base. And one of the equal side, these two sides are equal, are 3 less than twice the base. So if this is 3 less than twice the base, this is 3 less than twice the base. The perimeter is 44. So now I can do perimeter equals side plus side plus side, which is 44 equals b, which is the base, plus 2b plus 3, which is one of the sides, plus 2b plus 3, which is one of the sides. I'm just doing it underneath so I have room. I will collect my like terms. B's go with b's. I'm left with 44 equals 5b. I collect my constants, plus 6, and then I can use algebra to solve for the rest of that. And I won't do that for you, but that's how you would set that one up. Okay, the next one, we'll clear all this. I'm going to give ourselves some room here because this takes a bit of room to do. These are the money problems. So when you're dealing with money problems and these type of problems, they're all pretty much the same. Actually, all the way down, they're pretty much the same. So we'll just do number 7. It says, a jar of coins contains $18.50 in dimes and quarters. There are 110 coins in the jar. So we have dimes plus quarters has to give me 110. Right now we don't know how many of each there are. It looks like they're equal amounts. It doesn't say that you have twice as many dimes or 3 less. It just says you have dimes and quarters, so we assume they're all the same. So what we can do now is we can say, well, if I was looking at this, how many dimes, looking at this one here, how many dimes do I have? I know I have dimes plus quarters is equal to 110, but I can do this, minus Q, minus Q. So the number of dimes I have is equal to 110 minus the amount of quarters I have. And this is going to be quite handy later on. So if I need to know how many dimes I have, I can go back to this and I can reference it later. We'll go back to that in a second. The next statement says, you have dimes and quarters and they add up to $18.50. So we know that every dime is worth 10 cents plus every quarter is worth 25 cents, and that has to give me $18.50, which is 1,850 cents. I'm going to deal with cents over here, so I'm going to deal with cents there. So this will be 1850. So again, what the problem is I have 2 variables. You cannot solve this with 2 variables. You have to have 1 variable. So I look at D, and I look at Q, and now I come back up to here, and I say, well, wait a minute, I know what D is. D is 110 minus Q. So I substitute that back into here, and now my new question looks like 10. The number of dimes I have is 110 minus Q plus, leave this guy alone, 25 Qs, and that gives me 1850. So now what I've done in this is I have Qs that represent dimes, Qs that represent quarters, and I have no more D's in there, so now all I have to do is solve for quarters, and I can solve my problem. The whole crux of this whole problem is being able to do that part there. What I want to do is I want to use the initial statement to convert to just 1 variable. So now I can get rid of the D, and I can convert to this. And we'll work on that a little bit more, but that's the whole idea of these problems. Now what I'm going to do is I'm going to use this derivative property. And I'm going to go 110 times 10, which is 1,100, minus 10 times 1Q is 10Q, plus 25Q, nothing's changed there, and that still equals 1850. My next step is to combine the terms that I know are the same, which are these guys. So I'm going to be with 1100 plus 15Q equals 1850. Next step is the minus 1100 on both sides because I want to get rid of that. I'm going to run out of room here, but I'll be left with 15Q is equal to 650. So what I'm going to try to do is move this up. Oh, look at that. Good. Okay, so now I don't want 15 Qs, I want 1 Q, so 15 divided by 15 gives me the 1 Q. And I divide that by 15. And I'm going to look at this again and realize that I made a mistake here. So this should be 750. Because 1850 minus 1100 is 750. And now 750 divided by 15 is 50. So I have 50 quarters. The question wants to know how many quarters and dimes you have. I can go back up to my original statement of dimes plus quarters equal 110, which we had way up there. Put 50 in there to realize that minus 50 D equals 60. So I have 60 dimes and 50 quarters. That's a pretty complicated question, but the main idea of this entire project or this entire question is, can you take the original formula that they've given you, the original information, which is right here, 110 altogether, create a formula for it, an equation for it, convert that equation so that you only get one variable out of it, and then the rest kind of makes sense. So hopefully that works, and we'll do more of these as we go on, but that's how you'll have to do this. We'll try number 9 as well, just to make sure, and then we'll just keep going. Try to delete this here. Okay, we'll try one more. We'll try number 9. So Anne has 85 cents in nickels and dimes. She has 2 more nickels and dimes, so this is important. Okay, so she has 2 more nickels than she has dimes. So her dimes, so she has dimes and nickels. We'll let dimes equal dimes. Nickels, she has 2 more nickels than she has dimes. So her nickels are equal to dimes plus 2. If she had 5 dimes, she would have 7 nickels. So now we've already converted into one variable. The nickels have already been converted into dimes, 2 more than the dimes. Now we can look at what we have. She has nickels and dimes, and they add up to 85 cents. So now we write the money equation. We know we have nickels, which is 0.5 cents, plus dimes, which is 0.1, and that has to give me 85 cents. I would prefer just to get rid of all the decimals, so I'm going to multiply everything in my head by 10, and now I don't like decimals, I like just dealing with cents. So now I have this equation. I'm going to use this guy, wait over there, so when I go 5d plus 2 plus 10d equals 85. Again, the amount of nickels you have is dimes plus 2. I'll use my distributive property to get 5d plus 10 plus 10d equals 85. I'm going to combine this to get 15d plus 10 equals 85 minus 10. 15d equals 75. Divide by 15. D is equal to 5. So now I have 5 dimes. how many nickels do I have? Well, nickels was equal to dimes plus 2. So I have 5 plus 2, which is 7. I have 5 dimes and 7 nickels. And that's how you do those money word problems.